Right, let's take a look at this permutation problem. Permutation 2, given a collection of numbers, nums, that might contain duplicates, um, return all possible unique permutations in any order. So for this, I will have an approach as I did in permutation 1, which I was searching for all possible ways with recursion. And for that, I'll be creating the fs function. And in this function, we have to hold the frequency. We have to pass the frequencies of numbers, thinking then as like graph nodes. But we can have duplicates, so we will be using the frequencies of those to uh, to like backtrack while we are backtracking. So, and also we have to pass the path. So like our current path, like I'm gonna call it the current path, actually, like current path. And if our current path, the length of our current path is equal to the length of nums, then in that case we want to append to our results the current path, and we want to return because we don't want to continue in that path. Like we don't want to move on because like we just found our answer. So for that, like I said here, we will need results, and also we will be calling the fs dictionary, which will be actually the counter. Like I'll just pass the counter here because I have to hold the frequencies. I can just use the built-in counter function, and the current path is of course empty, and I just want to return the result here at the end. And for that, I have to import from collections. I have to import the counter, and here my counter will be equal to counter nums. And in this, I want to go every possible path. So let's say that we have like one, we can like, I want to look at the ones that start with 1. I want to look at the ones that start with the second one. I also want to look at the ones that start with 2. But as we see here, like here, we can have we can use this one and then use this one, and then in the next one we can use that and that and that one, and it just goes on like that. And so for every item in the nums, if the dictionary item is greater than 0, if we can use it, in that case we want to first mark that item by decreasing the frequency of it, and then we want to go we want to continue with that dictionary in that path, but we also want to append the current path, the current item, which is the current element in the nums. And also we, after this, since we are backtracking, we have to add that item, like increase the item's frequency by 1, so that we can use it in other paths. So let's say that you start with this, then you have frequency, just decrease it, then you cannot use it there. But in the next one, when you're like in that path, you cannot use that 1 again in this DFS. But in the next one, when you start with this one, you will just go on and use this because you should be able to use it. So we have to add it back to the dictionary, and so we can use it. So here, so let's take a look. What is this? So if it is not 0, see, I have some duplicates here, as you see. And what is the reason there? Okay, it looks like I have to continue with the rest like that. Just, just let me. Okay, let me think it again. Think about it again. So if you have more items, we just go decrease the count by one, and then you can use it just one by one again. But when you do that, you just in the next iteration, when you do that, you also don't want to put it in the dictionary if you have that in the path. So maybe we just want to check here at the end if we already have it, but in that case it will be 2 to the power of n times n, and which is yeah. I'm just gonna 1 second. Okay, so let's let's check. So when so I'm at this point, I'm just in the second iteration. When I'm here, I'm just looking at this, so I have duplicate. So I just don't want to look at the nums. I actually want to look at the dictionary, current dictionary, like the counter. Like maybe we can just, it's better to, yeah, but yeah, I mean that's fine. So we want to look at the items that are not in the current, like we don't have. So we just want to look at the ones like we have. So we just, when we decrease that at this point, we decrease it and then it is 0, and then we increase it, it goes on like that. But when we go down, when we decrease it, and we have to so we will be using the ones that are left, so that we directly go to the result and we don't go the paths that are like duplicate paths. So we have our results here, and yeah, it works like this. The complexity of this is every time we go dictionary, which will be the nums, length of nums, and 2 to the power of, that would result with 2 to the power of so sum complexity will be 2 to the power of n, and space will be of n, because we go as far as the length of the list, because we just stopped here in the base case. So yeah, this is the, so these are the complexities, yeah, space and time complexity. All right, I don't have anything else to add. So yeah,